Nanoceramic coatings. Before plunging into this wonderful topic that is a nanoceramic coating, let us try to understand the advantages of nanoceramic coatings over zinc phosphate coating. Okay, what are the advantages of nanoceramic coating over regular zinc phosphate coating? Zinc phosphate coating have been widely used in metal treatment for more than 5 decades. Still, there are some limitations of this zinc phosphate coating. The major issue is high power consumption. Of course, if it is any heat involved, that is any heating or heating equipments in other forms apart from the electrical heating, the heat energy, that is generally energy is consumed in the form of heat. And there is another problem of heavy sludge formation. So that poses the disposal issues. Disposal issues. Not only that, if it is a cold phosphating, the problem of prolonged processing time for room temperature phosphating. Nowadays, we have some modern metal pretreatment systems. Many use the salt gel technique. That involves hexafluorozirconic acid. Sometimes they use hexafluorotitanic acid also. And they incorporate additionally some adhesion promoters. Like polyacrylic acid or polyvinyl alcohol and tannic acid. They help to enhance the surface treatment, especially for painting. The main advantages of nanozirconic coating, that is nanoceramic coating. Such type of coatings use zirconium oxide. Instead of fluoride on the metal surface, so it helps in reducing the sludge formation. So naturally it is eco-friendly. Usually the zirconia, that is zirconium oxide, titania, which is nothing but titanium oxide, cerium oxide, zinc oxide. So such type of coatings are very popular for very good corrosion resistance. Now let us talk about some coating methods and materials. Nano zirconia coating, we used to call NZ, have been developed for various metals like mild steel, aluminum, and then GI, galvanized iron. In most of the cases, chemists use polyacrylic acid as the dispersant, and also ammonium polymethacrylate. So this helps in effective nano coating. And you must first of all prove that whenever you developed any nano coating, we should characterize the nano coating. That is, we should study the nature, the particle size, the thickness of nano coating. So that is called characterization of nano zirconia coating. Usually they are characterized by studying using AFM. These are various tools used in nanotechnology. Atomic force microscopy. Then scanning electron microscopy. And for corrosion studies, especially this EIS, that is electrochemical impedance spectroscopy. Electrochemical impedance spectroscopy. So all these are essential tools to characterize any nano zirconia coating or any nano coating. Nano means 10 power minus 9 meter. 1 Armstrong is nothing but 10 power minus 10 meter. When you take the hydrogen, its diameter is, that is 1 Armstrong. It means 10 power minus 10 meter. So let me consider 1 nanometer box, that is a box or a line with 1 nanometer. especially in representing all these units by symbols, you have to be very careful. So you have to put only small letter N for nano and then meter. If you put capital N and meter, it becomes Newton meter. Okay, so be careful, which is nothing but 10 power minus 9 meter. So 10 power minus 9 is bigger than 10 power minus 10, is it not? So that is how many hydrogen atoms can be placed on 1 nanometer scale? Can you guess? You can put 10, is it not? So take 10 power minus 9 and multiply by 10. So this is 1. So it becomes 10 power minus 9. So you can place 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like that. So each has 10 power minus 10 meter and this length is 1 nanometer. It means you can accommodate 10 hydrogen atoms in 1 nanometer. So whenever a particle size is at that is dimension, that is in the order of 10 power minus 9, they have the capability to organize by itself. It's called self-governance of nanomaterials. Self-governance of, they can arrange themselves like a robot. And that is why nanotechnology is very, very powerful. It can be microprocessed also. So we can trigger these nanoparticles and program these nanoparticles in such a way a particular task can be extracted from all these nanoparticles. And in fact, there is one concept called the self-assembly of nanoparticles. So it's called a SAM, self-assembly, self-assembled monolayer, that is molecular layer, SAM layer, it's called SAM layer. Now let me come back. So we can study all these nanomaterials using these wonderful tools. In fact, these nano coatings, for example, you have got the bare metal like this. This is bare metal over which you are forming a nano level layer. So this is a nano coating, and you should remember whether it is a nano coating or a phosphate coating. Phosphate coating is in the order of microns. Okay. So this is in the order of nanometer. So micron is bigger than, micron is nothing but 10 power minus 6 meter. 1 micron is 1 micron, means 1 micrometer, that is equal to 10 power minus 6 meter. So that is in the order of microns. Which one? Zinc phosphate coating. Whereas this one is in the order of nanometer. So you know very well, that is, it is very, very soft, mild layer. We cannot say soft, but it is a very mild layer. And both nano coating and phosphate coating by themselves, they are not corrosion resistant. You have to protect it by giving another layer of painting or greasing or oiling, etc. Okay, right. Now, because you have to remember and you have to tell your customers also. Most of the people, they are mistaken that just by giving phosphate coating and nano coating, they should withstand very high resistance. No. This acts as a very good anchoring surface. It is a sandwich layer only. So it is a fantastic sandwich between the bare metal and the top coat. It acts as a sandwich layer. It acts as a very good, that is the anchoring surface, are able to follow, so that the top coat is tightened further and it is totally free from any crevices or any because of its tight crystal lattice in the case of zinc phosphate. Remember that zinc phosphate is almost crystalline, whereas iron phosphate is amorphous. And this kind of nano coatings, this is also like a transparent layer. It won't be crystalline as we expect, as in the case of zinc phosphate. In the case of zinc phosphate, suppose assuming that this is a zinc phosphated layer means you can make a scratch. You can find the nail mark, but you cannot get such type of nail marks in nano coating. Nano coatings will be appearing like a gold lacquer, but it is very, very mild. Okay, right. Then, and moreover, both these coatings are hygroscopic. It can absorb moisture. Okay, so you have to be very careful. And that is why, in case of zinc phosphating, they are passivating. Nowadays, phosphating is almost banned, and not phosphate. Passivation is banned. Therefore, they go for double distilled final rinsing. Okay, right. Then, now let us go ahead with the commercial application and testing. How they are tested. Commercial applications and testing. Most of the nano coatings, or particularly zirconia coating, are based on hexafluorozirconic acid. Nowadays, commercial coatings are available, like in the case of Henkel, they are producing Bondrite, NT1, like that. Now, the corrosion resistance is tested against various environmental conditions and chemical conditions. Usually, the ASTM B117 is insisted for neutral salt spray resistance. American standard testing method B117 is the recommended procedure to test the corrosion resistance against various environmental and chemical conditions. Then the environmentally, apart from that, we have got so many tests, but I am just giving the summary. Environmentally safe solutions. Definitely, we should agree upon this eco-friendly alternatives of phosphate coating, and there arises nano coating. So, nano coating or eco-friendly because they do not form sludge, no sludge, whereas phosphate coating forms heavy sludges. And there is no heavy metals like chromium, nickel, manganese, etc. Now let me explain about the applications of this nano coating in other industrial sectors like marine industries. So applications in marine and industrial sectors. Nanoceramic coatings, they help generally in preventing microbial colonization. So that is why they are used as anti-fouling. In case of anti-fouling paints, they are used. Especially when you look at the ship or boat, this is the hull of the ship where you can find a lot of colonial growth of these barnacles, algae, and other marine features, I mean animals. And that reduces the speed, the nautical speed of the boat or ship also. It increases once again the weight. So we have to avoid the growth of this colonial growth of these microorganisms. So for which the anti-fouling paint is useful, where the nanocoppers are incorporated. In those days, they use a copper naphthenate and other copper-based items, but it is called that is this copper material should not go into the ocean and kill the what, the microbes. Okay, so that is hazardous to the marine animals. But instead of killing, we can retard the growth. Okay, so for which this nano coppers are very useful in the case of anti-fouling paints. Now let us discuss about the surface preparation and other aspects for any conversion coating. Surface preparation. See, you should agree with me that the high quality paint on a on a poor poorly prepared, that is surface prepared, poorly prepared metal surface is worse than average paint, normal paint on a clean and well prepared substrate. Okay. And as far as surface preparations are concerned, you should understand the importance of surface preparation. Many guys, they don't understand the importance of surface preparation. So first of all, as you know, the surface must be cleaned. There are two important enemies for paint. What are those? One is oil, another is rust and dust in any form. Okay, so that should be cleaned properly. And when you consider this surface cleaning, you can go for physical cleaning. What is this physical cleaning? Like sandpaper or sanding or sand blasting or grit blasting or mechanical polishing, etc. Okay, And it can be a chemical cleaning also. It can be chemical. And chemical conversion is different. Most of the people, they confuse with the cleaning and the conversion. So this is what we are doing as nano coating and the phosphating. These are all chemical conversion. But for chemical conversion also, the surface should be thoroughly cleaned either by physical or chemical means. So this is a very important stage for developing a good chemically converted surface, and thereby it is ready for further painting or top coat or priming followed by top coat. The primary cleaning methods. Primary cleaning methods. I would suggest as a manufacturer of that is metal treatment chemicals, you should always give some manual about the cleaning also. Okay, because most of the people, they are not aware about this, but it is your moral responsibility to teach them how it should be cleaned, all these things. So primary cleaning methods, that is, you can clean it by alkali. It's called alkaline cleaning, where we use that is sodium hydroxide, potassium hydroxide, all these things, caustic, etc. And it can be done by an organic solvent cleaning. So both of them are responsible for removing what? Oil, grease, etc. But without affecting the metal properties. That is very important. And if there are any surface marks, it should be properly polished. So metal polishing. If there are two marks, that should be removed. So metal polishing should be done. Metal polishing. And then, so it means you have to remove the rust and dust in any form. And you should be removing the tool marks also. And then some people, they employ acidic de-rusting. Acidic de-rusting. Usually they chemically removes oxide layer from the metal. Usually any metal, when it is exposed to sunlight or water and air, they form a layer called metal oxide, and this is nothing but rust. So we want to have a virgin surface of the metal, so the rust must be completely removed. And as far as the chemical conversion coatings are concerned, you have the inorganic chemical conversion coatings. Like, you know very well about this zinc phosphate coating, and you have iron phosphating, then manganese phosphating. Most of the people, they use manganese phosphating for oiling purpose, for machinery parts or moving parts, or they apply lubricant on especially tubes. Lubricant, they are using stearic acid also. Once they phosphate everything, over which they give stearic acid. This is manganese phosphating is heavy. It consists a lot of pores. Whereas zinc phosphating is intended for, that is, painting. And this is also for painting, but the zinc phosphate gives a better Salisbury resistance. So usually they give organic top coat as in the form of either powder coat or organic liquid paint coat. Then when we talk about the application on various metals and alloys also, you cannot employ a single solution for different types of metals and alloys. So you need specific formulations for each. For example, you have iron, that is mild steel, cold rolled steel, hot rolled steel, etc. And you have galvanized steel, galvanized iron, and the electro galvanized steel. Then you have aluminum and aluminum alloys. Then you have copper, manganese, zinc, titanium. So in all these cases, the key factor for quality coatings is effective cleaning of the base metal to ensure high quality conversion coating. And where is the need for this metal surface treatment? For example, what are the prerequisites? I would suggest you should never recommend the nano coating to the low scale operators and those who use very poorly treated mild steels or poorly stored mild steel. For a good nano coating, the metal should be totally free from rust. If they have got any rusted components, nano coating is nothing, it's waste. So you should have a very good surface and they should treat the raw materials, particularly these mild steel and other steels, as gold. They should treat this as a gold. You could have found most of the people, they simply store in open spaces, okay, so where they invite trouble unnecessarily, and actually the incoming material will be all right, but the problem here is that is we invite lot of trouble by keeping all these components, metal components before fabrication open to the atmosphere, okay. So prerequisites of surface treatment. So always identify the type of corrosion. If you notice any type of corrosion, so for which you should be aware of the type of corrosions. What are the different types of corrosion? Check for crevice corrosion. Then pitting. Pitting is heavy. And galvanic corrosion. This occurs in welded area. Galvanic corrosion. And creeping corrosion. And sometimes after painting, there will be some scratch found on the automotive parts. And in the scratch, you would have found some mild rust. So such type of corrosions are called cosmetic corrosion. So like that, you have crevice corrosion, pitting corrosion, galvanic corrosion, creeping corrosion, and cosmetic corrosion. So crevice corrosion, this is caused by stagnant electrolyte. Stagnant electrolyte means some acid or salt solution stagnant over certain area, metal area, and thereby corrosion is triggered. So it is due to what? Stagnant, we used to call electrolyte. Especially in joints, metal joints or surface deposits. Pitting is resulted from prolonged contact with corrosive acids on localized areas. So this leads to rough surface. Galvanic corrosion means this occurs when two dissimilar metals are joined, metal 1, metal 2. So especially you can find such type of corrosion in the welded area where you can find two dissimilar metals. So galvanic corrosion occurs when two dissimilar metals are in contact. Then cosmetic corrosion, as I suggested, it is visible on scratches of paint layer on sheet metal, and that lead to creeping corrosion also. You could have find, for example, if you have got a sheet metal like this, you have got already a painted one where you can find some scratch. In the scratch, you can find some creeping, okay? And in fact, we used to test this creeping corrosion in what? Salt spray. So thereby, it will loosen the painted surface and it will lift the paint from the base metal. I would suggest a mechanical cleaning for nano coating. Instead of disturbing the chemical system, you can have mechanical cleaning. For example, you can simply use the sandpaper with emery sheets, and then you can go ahead with the polishing. So this will actually enhance that is increase the active sites on bare metal. So this facilitates electrochemical reactions. So this will lead to better corrosion resistance. We have got various types of metal pretreatment. It's called a mill classification. According to mill classification, you have M type. So this is intended for the manganese phosphate coatings. And a Z type, this is intended for zinc phosphate coating. Nowadays, there are plenty of, that is, varieties of chemical conversion coating. You have traditional coating. Then you have modified coatings. You have nano enhanced coating. you have metal oxide coatings. Metal oxide coatings. So under traditional coating, you have zinc phosphate coating, manganese phosphate coating, amorphous iron phosphate coating. Under modified coatings, we have three types. Calcium modified zinc phosphate coating, low zinc manganese phosphate coating, low zinc manganese phosphate coating. Then zinc phosphate combined with nickel and manganese. They are called trication phosphate. Under nano enhanced, you have nanoparticle incorporated zinc phosphate coating. This is another technique, nanoparticle incorporated and zinc phosphate coating. And the latest trend is here the metal oxide based coating, where we use the zirconia coating, zirconium oxide. Cerium oxide, chromium oxide, yttrium oxide. Most of the people, they are mistaken that when we take a zirconium oxide coating, they take the zirconium, not like that. They don't take zirconia. It is converted into nano zirconia over the metal during the chemical process. So the starting compound is not zirconic oxide. Okay, so it is the oxide in the form of nano that is formed during the course of the reaction, that is metal conversion. Okay, but the starting compound is different, that is hexafluoro zirconic acid and titanic acid. And as far as applications are concerned, you can have variety of applications like three types application of nano coating and also phosphate coating, that is spray type, hot immersion and cold immersion. Usually the coatings are measured, phosphate coatings are measured in terms of weight per unit surface area. So you have to study in depth about the coating weight, how to measure the coating weight. But the nano coating weights are, it is not given as nano coating weight. It is given as only nanometer scale, that is in terms of coating thickness. But zinc phosphate coating is given in terms of weight only, coating weight only. Okay. So I hope that is we have discussed in detail about the simple introduction about the nano zirconic coating. In the next class, I will be explaining about how to select the suitable conversion coating, followed by what are the different types of materials used in ceramic coating. Then what are the precautions before taking up any nano materials, and then there are some important additives, okay, so which have to be incorporated in the nano zirconic coating. Okay, so all these things will be discussed in the next class.